All right, so this is another example, but we are going to do one thing a little bit different. So this is my function, but I want to know what is the slope of the tangent line at this point, and then again at this point. And if you actually look at the graph of this function real quick, like if you're talking about the point -1, 6, here's -1, so of course that would be somewhere along in here. And you're talking about the slope of that tangent line, that would come down through here, that would have to have a negative slope. The other point is 2, 3, so that point somewhere along in here, so therefore that tangent line would fall somewhere within this area, and that would be a positive slope. So because we're talking about two different points here, we don't need to go ahead and substitute the x value into the c. I'm going to go ahead and work it out, just leaving the c in the definition, and then when we're finished, we can substitute in the -1 and then substitute in the 2. If you do it now, you're going to have to work the same big long problem out twice. And this way we'll only have to do it once and then just do a quick little substitution at the end. Okay, so I'm going to have the limit as delta x approaches 0. Okay, now remember, well, let me just write my definition first. You have f of c plus delta x minus f of c divided by delta x. So I've got to apply this to this function. Okay, so I've got to evaluate it at c plus delta x. So I have to substitute c plus delta x here and here. So I'd have c plus delta x squared minus 2 times c plus delta x plus 3. Okay, so that's all of this. Now I've got to subtract from that f of c. So I've now replaced this x and this x with just a c. So because this is subtraction, put it in parentheses. So therefore I'll have c squared minus 2c plus 3. And that's all divided by delta x. Okay, so now we've got to go through and take care of all of our simplifying. Okay, you would want to write this down twice and full it out, so if you need to go over to the side and write it down twice so that you can see that, what you're going to have is going to be c squared plus c delta x plus c delta x plus delta x squared. Okay, distribute your 2. And then distribute the negative or the minus. Okay, now combining like terms, your c squares are going to add out. Your 3's are going to add out. Your 2 c's are going to add out. Okay, I can combine these two together. Those would be considered like terms. So that's going to give me 2c delta x plus delta x squared. And then I still have this minus 2 delta x. Now, just like before, when we were doing limits, if you start substituting the 0 in for the delta x too early, you're actually going to get the indeterminate form of 0 over 0. So if you do it too early, you'll know. I do still have some more simplifying that I need to do because all of my terms in my numerator have a delta x in common. So I need to factor out a delta x. So I will have 2c plus delta x minus 2. Okay, so now my delta x's are going to cancel out. So I'm left with 2c plus delta x minus 2. Now you can do the direct substitution, so you would substitute 0 in for your delta x. So therefore this just simplifies to be 2c minus 2. Now I could have worked the last problem exactly like this. I could have worked the whole problem out with the c's, and then I could have substituted the point, the x value from the point, once I got to the end. But if you've only got one point, then you can go ahead and actually substitute in a number, and have some real numbers to work with instead of just having to deal with so many c's and delta x's. But this time we had 2 points, so this is going to make this better because you don't have to go through all of this twice. Alright, so now you're going to take the 2c minus 2 and evaluate it for this point and for this point. So, starting out we got the negative 1/6. So we're finding slope, so I'll just say m equals, since we're talking about slope. So I need to replace the c with the negative 1 first. So that's going to be 2 times negative 1 minus 2. Of course, negative 2 minus 2 will give me negative 4. So the slope of your tangent line at this point is a slope of negative 4. But if you remember, I said when we looked at it that this one should have a negative slope because that line would have been falling or going down from the left to the right. Let me put it back up here just a second. So somewhere right along in here is that point. So your tangent line, see, comes down through here. And so the direction of that line, since it falls from the left to the right, remember, indicates that you have a negative slope. Okay, so now my other point is the point 2, 3. So this time I would substitute in the 2. So I'd have 2 times 2 minus 2. So 4 minus 2 will give me 2.